we're going to interrupt your normally scheduled program. I wish we could do a nice announcer's voice. We herewith interrupt your program with deepest regrets to show you a bit of prep you should do so you can get ahead of the game. The PCBs come fairly clean from the factory, but they almost always have some residue on the surface, and if they've been sitting around in storage for a while, they'll have a little oxide. So what you need to do is grab the little blue guy, which is for the Alps pot, and the main PCB, and there's a little blue scrubber in your hardware kit. Bring everything over to your sink and put a little bit of dish soap, just straight dish soap. You don't want anything that's got moisturizer in it or anything like that, and just soap up the scrubber and scrub in 4 directions. Just rotate.
No, you're not scrubbing a dirty pan or a pot here. It doesn't have to be too heavy. You're not trying to wear the text off of it.
And then rinse this in clean water. Do the main PCB like that. Both sides need to be given a quick scrub, and that'll facilitate a much better solder connection and no surprises later on. Now, here's the important bit. You've got to dry this thoroughly before you can start soldering, or you're going to have a hazard, because the moisture will actually start popping when it gets hit by heat, and the solder could come bouncing off of the board, which wouldn't be any fun.
So towel dry it, air dry it afterwards, or use a hair dryer or a heat gun to finish it off if you're in a rush, but let it dry properly.
Okay, back to your normally scheduled episode. Hey everyone, it's Jim.
And Charles.
From Mellow Amps. And before we start building, I thought we should take a quick look at the power supply schematic and just talk about what every component does in brief. So we've already worked on prepping the transformer. So you already know that this side here is the primary side, or the wall side. This is the low voltage region. This is the high voltage region. Everything on the secondary side of the transformer forward is identical. It doesn't matter what voltage region you are. So you'll note that we've got voltages marked in strategic places. That will help with troubleshooting and verifying when you first fire up your amp. And you'll note all voltages are approximate. Okay, so we've got approximately 212 volts AC on this side across the 2 blue secondary wires. And we've got a couple of fuses. That helps protect this side of the transformer. There's a fuse over here on the primary side. That helps protect this side. Now the primary fuse takes charge of the entire circuit, including the chassis. And the secondaries really are to make sure that the transformer, this side of the transformer, doesn't get damaged with a catastrophic failure on this side. We have a full diode array, so that's four diodes here.
Also called a full bridge rectifier.
Yeah, there's lots of different names for it. What that does is it takes our raw AC and it turns it into raw DC. And DC is what we run pretty much all electronic circuits on, with some exceptions. But this is a really rough DC.
If you look at it on a scope, it'll be really wavy.
Yeah, it'll look like a choppy day on the ocean, or on your local lake. So after that, we're basically filtering that and smoothing it out. So we have a choke that does an excellent job of smoothing out the DC. We've got some capacitors in here. They work in conjunction and help fill the raw DC. We have R1 here as an interesting little resistor. It's a very high resistor. 680K is 680,000 ohms. And what that does is when the amp is turned off, it trickle bleeds the positive voltage rail down to ground. And
all those capacitors get drained to ground.
Yeah. So it's basically a safety resistor. And because it's such a high value, when the amp is actually operating, it drains such a minuscule amount of power that it really is not consequential. That's why the value is set so high. Over here we have R2A and B, and at this point the circuit becomes basically two supply circuits, and it becomes a quasi dual mono supply at this point. And we end up with a final very large filter stage. So R2s and C3s, 390 microfarad, 450 volt, create a very effective filter that essentially only allows very clean DC through.
And from this point forward in the circuit, each channel's values will be marked in an A or B format. So you'll see we have two C3s, we have a C3A and a C3B. It will be the same further down through the preamp circuit.
Yeah, and the last thing I want to show you is we've got a little sub-secondary circuit. Then that is the filament supply, and that's part of the secondary windings. And you'll note that it is a center tapped feed, and what that means is we've got half the voltage on one leg, half on the other leg, and a tap in the middle to ground. So if we add these voltages up, we should get about 6.3. Now, you'll never get exactly 6.3. That's going to depend on your main supply, how close to the center value it is. But luckily, filaments can take a very wide range of voltages. So don't fuss. So long as you're somewhere between, let's say, 6 volts and 6.9 volts,
you're going to be just fine.
You'll be just fine. Okay, well, this is getting boring. How about we get a building?
Yeah, let's get back to the build.
Okay, so grab your transformer, and the orientation is going to be like this. So the white and blue and black wires will be towards the front. You're going to need 4 M3 by 8 truss head screws, along with one of the oversized washers. You're going to need 4 of these
small
M3
brass standoffs.
Yeah, they're M3 by 10s. You're going to need a 5mm socket or a 3/16 socket if you're on the old-fashioned socket sets. And you're going to need a Phillips driver. Okay.
And your top plate, of course.
Now, you can see we're working on a nice cotton cloth so that we won't scratch this top plate surface. Wire ends are particularly notorious for scratching anything that they rub against, so just be really careful. You might want to grab somebody to give you a hand. I've got Charles right here with me.
And I'll show you a little trick on how to keep them neat and stop them from scratching the plate as well.
So let's get that washer on the one leg that it needs to be installed. And this is going to help make a good ground connection. So it's going to drop in like this.
And before we do that, let's just grab an elastic and we'll bundle these up so they're facing upward. And now these wires are not going to touch the plate while we're working with it.
Brilliant. Okay, let's try that again. So you can see that the washer is on this leg where the paint has been cleaned off, and that's just to make sure we have a good electrical connection to ground. And that'll ground the whole chassis of the transformer. Now just drop the other machine screws in. It'll help hold everything in place.
Mm-hmm. And you don't want the transformer to slide around very much.
Okay, now get a finger on the first machine screw and just quickly spin on the standoff.
Don't put it on too tight. We are going to have to adjust the position of the transformer so it's centered in a minute.
Okay, I think you know what you're doing. I'll see you back in a second. Okay, so your transformer should be just a little loose so you can move it around, and you'll see why in a minute. Let's get that elastic off, and now we got to be very careful not to scratch things. the finish on this is actually very durable, but it's not impervious to getting mucked up.
So you want to slowly and carefully feed the transformer wires through the holes that are right next to them here. And you don't have to do them all at the same time. You can see we're splitting them up a little bit. There we go. And you'll want to feed it down and move the heat shrunk bundle so that it's fairly tight and off to the side a little bit.
Just like that.
Just like that. This might need a little bit of tweaking in a little bit when we get the transformer cover on, but just try and do as good of a job as you can there.
Okay, and then just do these primary connections, which are pretty bulky, one at a time, so that they fit. And
that little short ground connection.
Okay, I think you get the idea. Just fit it in there nicely, and I'll see you back in a second. Okay, so this is the way the transformer wiring should feed. So it's sort of on an angle to facilitate getting the cover on.
And we should still be a little loose here too. We'll tighten it down after we get the cover on over it.
Yeah, everything is a little snug. Now the cover really can go any way you want as far as the up and down is concerned, but I prefer to put the side with a nice finish on it up. And the easiest way to do the cover is just to do 1/2 at a time. So let's put that aside. You're going to need 4 of these standard M3x8s. And so just get it up onto its edge. I'm going to try to do this so you can actually see what's going on. And it's really not that tricky. Just be careful to not scratch your top plate. So
and to not cross-thread it as well.
So I'm doing this all by hand. Yeah, now if you start a machine screw and it doesn't quite go in right away, that's your cross-threading. So go in reverse with your thread. That's first thing in the morning here.
You should feel it pop, and then once it pops, you should be able to go. There we go.
Ah, we just heard the pop. So, and what that pop is, or click, is the lead of the screw dropping into the lead of the cut thread. Okay, so we got one on. Let's flip it over, and we'll get the other one on. And
now, if your wiring isn't very tight on the transformer here, you might have to pull it in to get into the right position.
Yeah, and I have that problem. So let's do this. Let's just take our time.
Yep. If there's a lot of resistance, then take your time and move the wire bundle just a little bit more over. You don't want it to get pinched.
Yeah, and we're just going to put these machine screws on loosely at the moment, and then we're going to tighten everything down. In fact, we do a lot of building like that, where we get everything in position, we take our time, and then we snug it all down when we're sure we've got everything right. So you can just adjust your wires a little bit to make sure that they're as snug as you can get them. And now you just line up the keying on the cover.
Yeah, these can't slide in from the side. They have to go up and down.
Yeah.
There we go.
Okay, I think you know what you're doing. I'll see you back in just a minute.
Yeah, just put it on loosely still.
One of the last things we need to do is to just center the transformer. It should be pretty close because there's not a lot of room, but just get it so that the transformer is basically in the middle, and ours looks pretty darn good. And just gently hold on to it, and then swing over and snug things down. Now you might have to put a finger on the head of that machine screw or a screwdriver.
And if it's a little snug already, then you should be able to just tighten it down there.
And check it, and yeah, it looks really good. I'm just using a finger just to hold on to it. And once you have all 4 of these on, then we're going to snug down the cover. So let's just take a look and make sure everything looks straight. The cover can move a little tiny bit, so just have a look at the cover and make sure it's lined up and looks square, and it does.
And snug it all down.
Okay, so now that everything's all lined up, just come in with your screwdriver and tighten everything up a little bit more. Now remember, these are M3 fasteners and they're going into a threaded aluminum case. So there's a limit to how much torque you can apply to it before it'll strip. So just apply a little bit of torque and you'll be safe. It's always better to err on this side of slightly loose than slightly tight. And same goes for these brass standoffs. You can put a wrench on it, but I'm going to show you.
Don't hold on to the end.
You've got maximum torque over here. You've got minimum torque over here, right at the place where the shaft is. So just give it a nice little tightening down, and Bob's your uncle. And sometimes these brass standoffs will actually get stuck on your socket, so just back them off slightly and they'll snap off. Okay, good work. What's next?